JDBC driver in Java database connectivity. Focusing on JDBC driver. A JDBC driver is a software component enabling a Java application to interact with a database. JDBC drivers are analogous to ODBC drivers, ADO.NET data providers, and OLEDB providers. Here you can see JDBC driver types. Type 1 JDBC driver. Type 1 JDBC drivers translate JDBC calls into ODBC calls. Type 1 JDBC drivers are usually called JDBC ODBC bridge drivers. Type 2 JDBC driver. Type 2 JDBC drivers translate JDBC calls into native DBMS APIs. Type 2 drivers consist of Java component and native code component, which requires that binary code be loaded on each client machine. Type 3 JDBC drivers are pure Java drivers that uses database middleware. Type 3 drivers communicate with the database through middleware servers that must be running in the network. The NET protocol allows the client JDBC drivers to be very small and load quickly. Fetching data rows may take longer because the data comes through middleware server. Type 4 JDBC driver. Type 4 JDBC drivers are pure Java drivers that accesses a database directly. The Type 4 drivers are sometimes called the thin drivers. Type 4 JDBC drivers have a relatively fast performance. Here you can see type 1, 2, and 3 and 4 drivers. In type 1, you can see in client here Java client or JDBC or DBC bridge and JDBC drivers are there. Java client is connected to JDBC ODBC bridge, and JDBC ODBC bridge is connected to ODBC driver, and ODBC driver interacts with data source. In type 2 you can see Java client, JDBC native library and native library are inside client tier. Java client is connected to JDBC native library. JDBC native library is connected to native library, and native library interacts with data source. Here Java client is inside the client tier. Java client is connected to middle tier. App1 applications and application server and three tier JDBC driver are in middle tier. Middle tier is connected to data source. In type 4 Java client and all Java JDBC driver are inside client tier, and Java client is connected to all Java JDBC driver, and all Java JDBC driver interacts with data source. Here you can see JDBC drivers and databases. Here Java application interacts with JDBC interface. JDBC interface is connected to driver Oracle, driver ODBC, driver Sybase here, and driver Oracle is connected to Oracle database. Driver ODBC is connected to Microsoft Access. Driver Sybase is connected to Sybase database. As an example, we can consider this database connection URL in MySQL, where localhost is the name of the server hosting your database and 3306 is the port number. Here you can see the syntax here. In here host colon port is the host name and port number of the computer hosting your database. If not specified, the default values of host and port are 127.0.01 and 3306 respectively. Database is the name of the database to connect to. If not specified, the connection is made with no default database. Failover is the name of the standby database. MySQL connector /J supports failover. Property name equal property value represent an optional ampersand separated list of properties. These attributes enable you to instruct MySQL connector /J to perform various tasks. As an example 2, we can consider this database connection URL in Java DB. You can see the syntax here. Here in sub protocol is specified where the Java DB should search for the database either in a directory, in memory, in a class path, or in a jar file. It is typically omitted. Database name is the name of the database to connect to. Attribute equal value represent an optional semicolon separated list of attributes. These attributes enable you to instruct Java DB to perform various tasks, including following. Point 1, create database specified in the connection URL. Point 2, encrypt the database specified in the connection URL. Specify directories to store logging and trace information. Specify a username and a password to connect to the database. As the example 3, we can consider this driver for this is for PostgreSQL. Before JDBC version 4 and Java SC 1.6, there was no generic mechanism in the JVM that would enable services to be discovered and registered automatically. Because of that, the manual step was needed to load the JDBC driver class by name. Here the method public static class dot for name string class name throws a class not found description here. If there's an error, and this method returns the class object associated with the class or interface with the given string name. here a call for name causes the class name here, this one, to be initialized. As the example 4, we can consider this driver oracle.jdbc.driver.oracle driver. Here this class for Oracle database. As the example 5, we can consider the driver class for the Sybase database, sybase.jdbc.sqlanywhere.idriver. As the example 6, we can consider this one. Here is an example of using tpipe to write the results of an SQL query on a table in MySQL database. The MySQL connector J is the official JDBC driver for MySQL. Once you have extracted the distribution archive, you can install the driver by placing MySQL connector java version bin.jar in your class path, either by adding the full path to your class path environment variable, or by directly specifying it with the command line switch cp when starting the JVM. Now we are considering types of drivers in connections. There are many possible these implementations are categorized as follows. The type 1 drivers that implement the JDBC API as a mapping to another data access API such as ODBC. Drivers of these types are generally dependent on the native library, which limits their portability. The JDBC ODBC bridge driver is an example of type 1 driver. Type 2 drivers that are written partly in the Java application language and partly in native code. These drivers use a native client library specific to the client source to which they connect. Again, because of the native code, their portability is limited. Type 3, the drivers that use a pure Java client and communicate with middleware server using database dependent protocol. The middleware server then communicates the client's request to the data source. Type 4, drivers that are pure Java, often using a network protocol or file IO to communicate with the specific data source. The client connects directly to the data source. There are many possible implementations in JDBC drivers. These are the categories. Now we are considering driver interface. Example is static initializer for a driver implementing here. Driver implementing a java.sql.driver. Here the when a driver implementation is loaded here, the interface driver in package java.sql, in module java.sql, the interface that every driver class must implement. JDBC drivers must implement the driver interface, and implementation must contain a static initialization that will be called when the driver is loaded. This initialization registers a new instance of itself with the driver manager as shown in this example. When driver implementation is loaded, the static initialization will automatically register an instance of the driver. To ensure that the drivers can be loaded using this mechanism, drivers are required to provide a no argument constructor. The driver manager class invokes driver methods when it wishes to interact with the registered driver. The driver interface also includes the method accepts URL. The driver manager can use this method to determine which of its registers driver it should use for a given URL. When a driver manager is trying to establish a connection, it calls the driver's connect method. And passes the driver URL. If the driver implementation understands the URL, it will return the connection object or throw a SQL exception if the connection cannot be made to the database. If the driver implementation does not understand the URL, it will return null. Loading a driver that implements java.sql.driver. As part of its initialization, the driver manager class will attempt to load available JDBC drivers by using the JDBC.driver system property, which contains a fully qualified list of class names of JDBC drivers. Each driver is loaded using the system class loader. Service provider of the java.sql.driver class. For service providers of class that are loaded via the service provider loading mechanism. JDBC 4.0 drivers must provide a support for service providers of the java.sql.driver class. This is loading a driver using JDBC.drivers system property. Note the driver manager initialization is done lazily and looks up service providers using the thread context class loader. Drivers loaded and available on the application will depend on the thread context class loader of the thread that trigger the driver initialization by driver manager. When a driver manager.get connection is called, the driver manager will attempt to locate the suitable driver from among those loaded in the initialization and those loaded explicitly using the same class loader as the current application. Existing application currently load JDBC drivers using class.forName method will continue to work without modification. Now we are considering driver action interface. So here the example is static initialization for driver implementing java.sql.driver and java.sql.driver action. Interface driver action in package java.sql in module java.sql, an interface that must be implemented when a driver wants to be notified by the driver manager. JDBC driver may implement a driver action interface when the driver wants to be notified by the driver manager method deregister driver. The driver action implementation is not intended to be used directly by applications. A JDBC driver may choose to create a driver action implementation in a private class to avoid it being called directly. The JDBC driver's static initialization block must call driver manager.register driver java.sql.driver, and then java.sql.drive action, in order to inform driver manager which drive action implementation to call when the JDBC driver is deregistered. Here the example is static initialization for driver implementing java.sql.driver and java.sql.drive action. Now we are considering packaging JDBC drivers in connector RAR format, RAR file format in relationship to connectors. This is an example of a resource adapter deployment descriptor. Resource adapters can be packaged along with the deployment descriptor into a resource adapter archive or RAR file. The RAR file contains the Java class or interfaces, native libraries, deployment descriptor, and other resources need to be deployed to the adapter. The deployment descriptor maps the classes in the resource adapter to the specific roles that they perform. The descriptor also details the capabilities of the resource adapter in terms of what level of transactional support it provides. The kind of security it supports, and so on. The code example here is an example of a deployment descriptor for JDBC driver. The class com.acme JDBC manager connection factory could be supported by an implementation of a javax.sql.x data source. The resource adapter section contains the information on the level of transaction support. The mechanism used for authentication, and configuration information for deploying the data source in the JNDI space. JNDI namespace. Example, we can consider class not found exception in if the class cannot be located in the method for name string class name in class As an error example, we can consider this error occurred in the environment with MySQL on Tomcat 7.0 server. there is com.mysql.jdbc.driver occurred as a result of class not found exception.